Chapter 1, Section 8, Perimeter, Circumference, and Area. Take a minute to copy down the following formulas. For a square, how to find the perimeter and the area. Triangle, perimeter, area. Circle, circumference, which is basically the perimeter of the circle, and the area. And for a rectangle, perimeter, and area. Keep in mind that these are formulas for perimeter, but essentially you're just adding up the lengths of all of the sides of the shape. For a square, all four sides are congruent, 4 right angles. Rectangle, opposite sides are congruent, 4 right angles. For a triangle, the height is the line that's perpendicular to the base, which is the bottom of the triangle. The radius in a circle is half of the diameter. And when we use pi, we're never going to write or round it to 3.14 unless the directions say to do so. Otherwise, we leave our answer in terms of pi, or we round to the nearest decimal place that's being asked in the question. So, the following example says the botany club members are designing a rectangular garden for the courtyard of your school. They plan to place edging on the outside of the path. How much edging material will they need? So basically what it's looking for is how much will they need to fill in this area. So you need to find the area of the bigger rectangle, the area of the smaller rectangle, and subtract them. So if this is 4, this is 22, and this is 4, then this entire side is going to be 22 plus 4 plus 4, which will give you 30. And on the other side, 16 plus 4 on either side is going to give you 24. So we're going to find the area of the bigger rectangle by multiplying the base times the height. So 30 times 24, you get 720 square units because we're not sure of the measurement that they're using. The smaller rectangle is easier. We know that this side is 16, this is 22. So 16 times 22 is 352. Then we're just going to subtract the area of the bigger rectangle minus the area of the smaller rectangle. And that will give us the area of the remaining space. So the amount of edging material that they will need is 368 square units. Next, we're going to talk about finding perimeter and area in the coordinate plane. So we're going to start out with a little bit more of a basic one, but please plot this on a sheet of graph paper. Draw your axes, label your grid, and label your points. So we have a triangle GEF, and we want to find the perimeter and the area. Well, when we're finding the perimeter, when it's a horizontal or a vertical line, we can just count the boxes. So for the base of this triangle, 1, 2, 3, 4, 5, 6 units long. And for the height, we have 1, 2, 3, 4, 5, 6, 7, 8 units, which you can also see by looking at the y coordinates. They're 8 units apart. Now, we can also see that this is a right triangle because a vertical line meeting a horizontal line makes a 90-degree angle. So we can either use the Pythagorean theorem to find the measure of the hypotenuse, or we can use the distance formula. Let's try to get in the habit of using the distance formula for when we start proofs. So we're going to do the difference of the x-coordinates. So -3 minus 3 squared plus the difference of the y-coordinates, -2 minus 6 squared. So -3 minus 3 gives us -6, and -6 squared is positive 36. -2 minus 6 gives us -8, and -8 squared is 64. This simplifies down to the square root of 100, which when you take the square root it's positive or negative, but when we're talking about length or distance, we're just going to take the positive square. So we get that the measure of the hypotenuse is 10 units long. And this makes sense because this is a Pythagorean triple. We know about the 3, 4, 5 triangle. If you multiply each of those by 2, if you double all of the lengths of the sides, you will get a 6, 8, 10 triangle. So to find the perimeter, we're just going to add 6 plus 8 plus 10, and that's going to give us 24 units. Now to find the area of a triangle is 1/2 the base times the height. So 1/2, the base is 6, the height is 8, so we get half of 48, which is 24, and since we're talking about area, it's units squared. Now the next example is a teeny bit more complicated because this isn't a shape that we know how to find the area of. There are certain circumstances where you can break it apart and find the area of each piece and add it together, but a simpler way to do this is to outline the shape in a square or a rectangle. So you want to hit the widest point. So in other words, this point right here is going to determine our left side. These 2 points, the highest one determines our top, our bottom, and then this side just happens to be vertical. So what we're going to do is we're going to find the shape of the outer edges and subtract all of these triangles. So we can see that the right-hand side is 5 units long. The top is 5 units long. So this is a square. Sometimes it's going to work out to be a rectangle, but in this case we have a square. So now we need to find the area of each one of these triangles. So again, 1/2 base times height. Well, here the height is 1 unit. The base is 2 units. So this triangle is going to have an area of 1 unit because 1/2 of 2 times 1 is just 1. This triangle here, we can see that this is a 4 and this is a 3. 1/2 of 4 times 3, 1/2 of 12 is 6. And then the base, this is a 1. And then we have 1, 2, 3, 4, 5. I know it looks like a very small piece, but the triangle ends here, so you count that whole side. 1/2 of 1 times 5 is going to give us 2.5. So the area of the whole thing, the area of the square, is 5 times 5, which is 25 units squared. Then we're going to subtract from it the area of each triangle. So minus 6, which will give us 19, minus 1, which will give us 18, and minus 2.5, which gives us our final answer of 15.5 units squared. And that's the area of this figure. Finally, we have the area addition postulate. So we've talked about segment addition postulate, we've talked about the angle addition postulate, and now we have the area addition postulate. So the area of a region is the sum of its areas of its non-overlapping parts. So in other words, we're going to divide these figures into parts that we know how to work with. So we see here our right angles in this first figure. We're going to divide this into 3 rectangles. The top rectangle is a 1 foot by 5 foot, so base times height gives us 5 square feet. The next one, 4 foot by 2 feet. Well, this is 4 feet. This piece is 2 feet, but we want to know the whole thing. So we see that this piece is 1, which means this piece, the base the top and the bottom must be equal. So this must also be 1. And 1 plus 2 gives us 3. So we're going to do 3 times 4, which is 12 square feet. Finally, we have this rectangle. Well, if this piece is 3, then this piece must also be 3. And this piece is 8. So 8 plus 3 gives us 11 for the whole side. 11 times 3 gives us 33 square feet. So we have 5 square feet, 12 square feet, and 33 square feet. Area addition postulate says that we can now add 33 plus 12 plus 5, and this gives us our final area of 50 square feet. The next example we can see, the easiest is going to be to cut it into a right triangle and a rectangle. So let's do that here. Now, if this is a right angle, then this must also be a right angle. So we have a right triangle here. We can use the Pythagorean theorem to find out the missing edge. So we have that the height is 6 inches, the hypotenuse is 10 inches, and we need to find the base. So a squared plus b squared equals c squared. We're going to get 6 squared plus b squared equals 10 squared. 36 plus b squared equals 100. B squared equals 64, which means that b is 8 when we take the square root of both sides. So if this piece is 8, and we know that the base here has to be congruent to this, 22 minus 8 gives us that this piece must be 14 inches. So now we have the measurements of all the pieces that we need. So we're going to add the area of the triangle, which is 1/2 the base, which is 8, times the height, which is 6. So 1/2 of 48, which gives us 24 square inches, to the area of the rectangle, which is 7 times 22, which gives you 154 square inches. Then we add the area of the triangle to the area of the rectangle, and we get 178 square inches.